introduce, my name is Darwis. So in Sumatera, I'm student in University North Sumatra, and my professor Muhammad Jarlis, Herman Mawengkang, and Opim Salim Sitompul. And now I'm student in computer science faculty, University Sumatera Utara, and I'm a lecturer in University Methodist Indonesia. The title of my paper is Forest Fire Prediction in Northern Sumatra using support vector machine based on the fire weather index. The issue of forest fire, an issue that continue to develop today. Various efforts have been made to reduce and prevent land and forest fires. The use of science is very important, one of which is machine learning to learn and can classify and prediction. And you know, in Indonesia, fires often occur in Indonesian forests. Forest fires are a major environmental issue, creating economical and ecological damage while endangering human life. The investigation and survey for forest fire had been done in Aek Godang, northern Sumatra, Indonesia. There is 26 hotspots in 2017 close to Aek Godang, North Sumatra, Indonesia. In this study, we use a data mining approach to train and test the data of forest fire and the fire weather index from meteorological data. And the aim of this study to predict the burn area and identify the forest fire in Aek Godang area, North Sumatra. The results of this study indicate the firefighting and prevention activity may be one reason for the observed lack of correlation. And the fact that this data set exists indicates there is already some effort going into fire prevention. And this is an example of image of forest and land fires. Yeah. And the related work, I'm using Aek paper, Canadian Woodland Fire Information System. Forest fire estimation using support vector machine is as approximator, a determining approach to predict forest fire using meteorological data, attribution of role of climate change in the forest fire Sweden 2018, and classification algorithm analysis in the forest fire detection problem, artificial intelligence for forest fire prediction, and early forest fire region segmentation based on deep learning, and the last predicting wildfire using data mining. Forest fire are important environmental issue, growing reasonably priced and ecological damage with endangering human life. Every year, North Sumatra of Indonesia spend hundreds of thousands to deal with the wildfire breakout. This is situation now not slowly motive monetary damage, however, can additionally disrupt the ecological stability by way of destroying vegetation and plant and fauna. Wildfire is additionally accountable for our pollution and change in climatic circumstance over the period of time. Over the decade, forest fire has to turn out to be a major problem. It has endangered the life of species. Regardless of the massive charge concerned in controlling these dead fires, they are additionally an essential problem in forest fires. The forest on the border of Aek Godang area, northern Sumatra, had been badly affected and would be impacted through different areas in North Sumatra. The primary trouble of this study, how to computation the hotspot in this location to predict the woodland fire. Firefighters are conscious of how forest fires can be unpredictable. However, if this data is obtained through them as a warning about the breakout on the then this form of phenomenon can be anticipated, controlling mainly can be prevented. Many typical science deal with wildfire hazard analysis. In the study, based on the description above, we are aiming to remedy this trouble via a historical analysis of woodland and land furnace fact and the use of weather data to predict the extent of fires that have occurred. Then we also explore information mining strategy to locate out, then predict the depth of wood area and land fires. Fast detection is a key component for controlling such a phenomenon. In achieve this, alternative options are needed. One of them is the use nearby sensor-based automatic equipment furnished by using several meteorological stations, causing a meteorological condition such as temperature and wind to affect the wood area and land fires, as well as knowing what a furnace index, such as the fire weather index, makes use of this data. FWI is primarily based on the speed index about the speed of furnace and wind speed. Then the build-up index to calculate the quantity of gasoline that reason a fire. Data and methods. The dataset of this study had been collected in BMCG, or in Indonesia, say a Meteorology and Climatology Board of Aek Godang Station, North Sumatra, from 2017 years. And next, from the LAPAN, based on the satellite of NOAA, and from PKHL, Direktorat Pengendalian Kebakaran Hutan, or Directorate of Forest Fire Control, there are more than 26 hotspots in 2017 close to Aek Godang, Northern Sumatra West record. This is locate my research at Godang in Northern Sumatra. The fire weather index structure. Before to calculate the FWI, the first we to calculate the fine fuel moisture code FFMC. Next, Dove moisture code and drought code. After to calculate this, next to fire behavior index, initial spread index, and to calculate the build-up index. So the finally to calculate fire weather index. And this is a formula and equation for the each fine fuel moisture code, Dove moisture code, drought code, initial spread index, and build-up index, and the last to calculate using formula fire weather index, this one. So the FWI index is an indicator measuring fire pace intensity and combining the two preceding components. Although the scale used is distinct for each issue of the FWI, the perfect cause may also indicate extra server combustion condition. Then the different vital element is the gasoline humidity code requires reminiscence of the preceding climate condition is 12 days for DMC, 16 hours for FFMC, and 52 days for DC. This is an essential indicator in figuring out the depth of the wood area and land fires that take place. This is a formula to calculate mean absolute deviation and root mean squared, which can be computed as equal 1. And in both metrics, lower value result in better predictive models. However, the RMSI is more sensitive to high errors. Another possibility to compare regression model is the regression error characteristic curve, which plot the error tolerance x-axis given in terms of the absolute deviation versus the percentage point predicted by the support vector machine by presenting in theoretical advance over the neural network, such as the absence of a local minimum when optimizing the model. This is formula 2. And this is formula 3. Yeah, represent a nonlinear transformation according to the kernel function to estimate the best support vector machine. The insensitive loss function is often used in presenting hyperparameters and less numerical difficulty than other kernels such as polynomials and sigmoid by using the popular kernel radial base function. This is formula 3. And the SPM performance is affected by the three parameters. See a trade-off between the model complexity and the amount up to which deviation larger than element are to related element, the width of the insensitivity zone, and y the parameter of kernel. This is an example of linear support vector machine regression and the insensitive loss function. The result and discussion. Predicting the fireplace burn of Aek Godang, the northern Sumatera region must assist in directing results over large area, and exceptionally interpretable model might provide recourse on health prevention. One may consequently be inclined to seem at multilinear regression or generalized adaptive models. The result of the split the statistic into coaching and trying outset is shown in figure 3. This is figure 3, the distribution of the response variable. And the response variable burn of Aek Godang North Sumatra is extraordinary skewed towards small fires. It might be beneficial to transform this with log 10 scaling. The visual spatial statistic result of this study is proven in this figure. Most fire manifest at central and low X, Y coordinates, except of one very high hard count grid reference, grade 8.6, comparing complete fires with the total burn region. There is some proof that fires at low X are small and numerous, where fires at high X are much less accepted, however large. This is a figure visualization spatial statistic. And the median burn region in figure 5 reinforce the remaining ballet that is today smaller fires dominate low X regions. the place large fire dominate at high X region. This is a median burn area. Based on the expert, the average burn area is biggest in March, March in figure 6. However, this may also be the result of a single or few fires in view that the width of the distribution is small. The greatest fire tend to occur in the summertime months, August, after to September. There is no obvious fashion in location burn on given day of the week. This is a categorical variable. And figure 7, the fire depends as characteristic of months and day appears like most fires take place in the summertime months of August through September. Most fires manifest on the weekend, possibly pointing the human recreation. This is the fire count as function of month and day log. And the FWY symptoms are all correlated with one another and with temperature. There may also be some multicollinearity, which will amplify the variance of the grid up model. It may be beneficial to mix this into a single predictor. We'll stick with the full set of predictors for now. This is correlation matrix. Based on the figure 8 correlation matrix, the cross-validate implant absolute error from beginning is 0 from 0.9. Using default hyperparameter is not the most strong way to examine fashion in this way, but well assumes that the default hyperparameters are set to give practical starting point for most problems. This is very disappointing. The mannequin predict a nearly regular response. There also appears to be a lower limit on the expected burn area. Does this mirror a lower restriction in the coaching data? It would be prudent to inspect this further. This is image the test prediction again the true burn area. And training and test data and set deviance. The test set deviance increase beyond 100 iteration, a clear signal that the model is overfitting. It would have been useful to do this checking out on a separate validation dataset as an alternative to the check set. This would have allowed us to go back and address the overfitting. Unfortunately, this is a very difficult dataset to work within, that it's small with few, if any, predictors nicely correlated with the response. We would likely now not get any reward for similarity, reducing the measurement of the coaching set. This is a feature training and test set deviance. All deviation give comparable consequence and are tremendously poor. Gradient boosting give the lowest cross validation error, so we will take his forward and attempt to tune the parameters. There is no huge correlation between any one of the predictors and the response. A multilinear regression or generalized additive model is probably no longer going to eke out a signal. Highly nonlinear techniques might be better suited and the rate of interpretation. This is feature importance. And many of the point have little or no significance in the closing model, they are probably adding noise, indicating that some future selection might be prudent. The temperature has the Asian significance of all the futures, which makes a lot of sense. However, its wind and rain have no importance. One might have expected fires to burn much less vicinity at instance of high precipitation and for high winds to fan the flames. The wood area fires dataset used to be present in Cortez and Moraes, 2007. The place the author's current and answer to this trouble, the use of a trained support vector machine in assessing the accuracy of their mannequin, they produce a REC curve, which plots the errors tolerance x-axis given in terms of absolute deviation versus the percentage of point efficient and the tolerance y-axis. The ideal regressor should be existing REC region close to 0.5. Gradient boosting based totally on the cross-validate mean absolutely. Error from Chern gradient boosting is 0.07. It performs characteristic selection naturally. However, with the use of validation set, it would have been feasible to use the future importance plot above to do some guide characteristic selection. In particular, most of the days and months have no relevance, to the problem and are probably sampling including noise. Unfortunately, the use of a validation set for this motif would always reduce the coaching data, in addition to contributing to the situation of attempting to eke out a susceptible sign from a small data set. Thank you. I'm sorry. The conclusion. Based on the result, there is a little correlation between the predictor variables and the response variable. It would be prudent to attempt and understand this lack of correlation better. Fire hostility and prevention exercise may be one motive for the found lack of correlation. The fact that this dataset exists suggests that there is already some effort going into health prevention. One ought to imagine a situation in which many fires can emerge as very massive but are extinguished before they have the risk to do so. If statistics about furnace prevention are reachable, it would likely be an extraordinarily precious addition to this dataset. It was once shown that the gradient boosting model used to be likely overfitting. Controlling the depth of timber and studying charts are two methods which are used to stop overfitting. Scikit-learn give numerous more, which includes the capacity to enforce a decrease bound on the number of samples in the leaf. This limits the ability of boosting algorithm to structure leaves that size single outlying data point, hence decreasing variance of overfitting. As with random forest, introducing randomization into the boosting algorithm can additionally minimize variance. Scikit-learn efforts two methods. First, by developing each tree with a random subsample of the education set, And the second, via randomly subsampling the points few for each node. In summary, a whole lot greater tuning of the manikin is possible. Thank you.